Hello again, YouTube. I'm back, and this time I'm going to be talking to you guys about one of the physics lectures that I went to this semester. The one that I found was pretty interesting was the one on cosmic rays. So let's go ahead and get started and talk about what exactly a cosmic ray is, because I had no idea before I went to this presentation. So, what is a cosmic ray? I mean, essentially, it's a really high energy particle that comes from space, and it just travels really fast into the atmosphere. And if it's going fast enough, it may make it all the way down to the Earth's surface. But okay, so you're telling me that there's these crazy particles that are just coming out of nowhere, what I still didn't get it after I heard this from the speaker, because it was just a bunch of protons just shooting down from the sky, which is fine. So as the talk went on, we learned a little bit more about exactly how fast they're going. They're going so fast that we can't even really reproduce. We can't even really reproduce them with the Large Hadron Collider that we have. They need 40 million times more energy to be equal to that. Well, what they're getting at is they're getting speeds of 3 times 10 to the 20 EVs, which is really freaking fast. So freaking fast. It's not even funny. They essentially, one freaking proton has the same amount of energy as a 60-mile-an-hour fastball. That's just one proton. There's a lot of protons that are coming. So that kind of blew my mind when they were talking about that. It's crazy, man. So why exactly do I care about these? They're just really fast protons, which, okay, cool. So you can spend all this time looking at them and kind of just saying, okay, there's these little protons, but they're not really doing anything to me. Are they? Am I always being hit by cosmic rays? Did I just get hit by one right now? I don't know. So the biggest point about this is that they can, when they're going through the atmosphere, there's a lot of stuff that's just going on as the Earth is just going about its day-to-day life, right? And as these particles are going through the atmosphere, they're gonna hit the nitrogen and oxygen molecules that comprises most of the atmosphere. And since most of these cosmic rays are positively charged particles because they're protons, this can cause these guys to become ionized, and essentially this whole process is what can influence things like ozone depletion, and it can even cause lightning to just start at the certain locations, because there's just lots of positive particles shooting through, and the negative particles need to go somewhere. And if there's a concentration of cosmic rays in one area, then it's just gonna cause lightning. And other things like this computer that I'm using to record this lecture could be affected by cosmic rays. Even companies like Intel have come up with ways to account for cosmic rays in their processors, which is really interesting. Satellites and airplanes care about these because they need to have uptime. They need to be there, and for them to they need to function and not be really affected by the radiation from space. So learning about these and how they affect our microelectronics can help us with certain, help us explore space better and figure out why things went wrong even in certain space flights. Because there was a story that I read on the internet about a space flight that one single bit in its computers got flipped, and the whole flight kind of failed. So you got to be really careful and account for this kind of these kind of cosmic rays that are really hard to see and account for as it goes on. So now that as we've gone over like how fast they are, what they are, like where exactly do they come from? We know that they come from space. Okay, so it's just coming from space. So let's think about this. So we have the Earth, and we have a star that we're kind of like moving around, called the sun. What is going on there? There's got to be, we're constantly being hit by radiation from the sun. Is that like a cosmic ray? How is that different than light that we're being hit by, So the main source of these guys are things like supernovae, stars, quasars, and gamma ray bursts. And the problem with necessarily like pinpointing where they come from is that this is an extremely difficult task. Why is this, you ask? Well, the reason why is that these particles are charged, and what that means is as it's going through space at a high velocity, chances are it's probably gonna hit something or just be moving along and may collide with another particle. I mean, if it never collides with another particle, then I don't know, like chances are something's gonna happen to it, right? And there's gonna be other particles going along with possibly different charges than the particle that's just moving through space. And it'll move through and be influenced by all those things. And as a result is when we try to like look at where exactly this particle has come from, the graphs that we can like make as we trace their paths look really random, and there's just like lots of lines just going everywhere, and we don't really get a clear picture of where exactly the true origin of these particles are. So as the particles come down into the Earth, they're going to be hitting like particles in the atmosphere, and when this happens, they can produce these secondary particles, and those secondary particles can also produce secondary particles, and so on and so forth. So let's kind of see if I can find something to explain this. So there's like one little particle coming down. It's going to hit a bigger one. See, this is like a penny, and this is a quarter. It's going to hit them, and then they're just gonna suddenly just become more and more particles, and keep going for a really long time. Now, this is something that can really complicate things, but using knowledge of physics and how these interactions occur, we can find, based on like the paths of the particles after they split and whatnot, where they would have come from. So this is a lot of complicated physics in here, but it can really help us to figure out the exact sources. But in order for us to really figure out where they come from, we need a way to like actually observe them. And how exactly do we go about doing this? Well, there are these places called, well, observatories, which we've heard about. Like there's telescopes and whatnot with stars. So what's the big deal about doing it with cosmic rays? Well, we don't really know where cosmic rays are gonna be heading. They just kind of come in as they please, and we need the large area to be able to really detect this. So we have the Cherenkov telescopes, which is one of the main observatories for these guys, and it looks at where like gamma rays come from cosmic radiation, and they need lots of space. I'm talking like 3,000 kilometers just to be able to detect like a couple particles in a certain period of time, and the conditions need to be perfect. Like there can't really be that many many clouds in the sky that day, as things like clouds are going to affect the protons that are coming in as well. So all these conditions need to be lined up for this to allow us to have successful observations. So those are the main ways that we observe them. There's other ways, but they get to be quite complicated, and as we continue to look at the ways that cosmic rays come down to the Earth, scientists are discovering just more and more insights on things like space and ways that we can possibly protect our atmosphere and better it for just to protect us from things like global warming, as ozone depletion is important, pretty important stuff. I mean, and yeah, that's pretty much it on cosmic rays. There is a lot of interesting stuff that was presented and lots of cool, complicated physics going on. Thanks for watching.